Hi guys, today we're going to learn about differentiation rule for products, quotients, secants, and tangents, more specifically about the product rule. So let's start with the product rule. So we say that we have a derivative of, if we want the derivative of f of x times g of x, that's going to be equal to f of x times g prime of x plus g of x times f prime of x. With this being said, this is the formula that you have. Please note that the f of x is the first function that you see, the g of x is going to be the second function that you see. Okay, remember this notation means the derivatives, okay? They are multiplying each other here and here. Okay, so we have this problem over here, y equals x cubed cosine x minus 2 sine of x. We want to find the derivative y prime. So if we want to find y prime, the first thing that you recognize is the product rule has nothing to do with that term. So we can easily say that that is going to be equal to negative 2 cosine of x. Okay, that one is just applying what we know about, the cosine and sine derivatives that we covered the other day. Now, the product rule, it's here. You can see that the g of x is the x cubed and the f of x is going to be the cosine x, or vice versa, right? So you want the first one times the derivative of the second one, which is negative sine of x, plus the second one times the derivative of the first one, which you know that it's going to be 3x squared. Okay, so you have a situation like that. Honestly, with so many parentheses, it looks kind of ugly. So what I'm going to do here is I just take out the parentheses, organizing the situation. So I have negative x cubed sine of x plus, and then I have 3x squared cosine of x minus 2 cosine x, and that's what we have for this problem. Now the quotient rule tells you that the derivative with respect to x of f of x divided by g of x is going to be equal to g of x times f prime of x minus f of x times g prime of x divided by g of x squared. Please note that basically who is in the numerator and denominator, it does matter, and then this is always for g of x that is different than 0. Okay, so for this one we're going to apply the quotient rule with your sine of x being the f and the x cubed is going to be your g. So in this situation we have bottom times derivative of top, which is cosine of x, minus top times the derivative of the bottom, which is 3x squared. This is going to be divided by x power 3 to the power of 2, so that's going to be x power 6. Okay, so you have the situation, and when I see this situation, I can see that I have a lot of x's, so I can cancel a little bit the x's that I have. So I have x squared as a common factor, so I have x cosine x minus, and then I have 3 sine of x, close it, and then you have the x power 6. So here you can see that that x squared is going away. Okay, so you have that this is going to be g prime is going to be equal to x cosine x minus 3 sine x divided by x power 4. Okay, so that's going to be your derivative for this expression that we have using the quotient rule. For the next problem that we have over here, we have several options. You can use a quotient rule, you can use a product rule, you can use a power rule. Okay, so let's use the power rule for this one. So if you want to use the power rule, you know that this I can split it like x squared divided by x to the 1/4 plus 2 divided by x to the 1/4. Okay, in order to apply the power rule, first you need to combine your variable, well, the exponents of your variables here, or you need to have only one variable, meaning that you have 2 minus 1/4, so this is going to be x to the power of 7/4. Okay, then I pass that x with exponent negative like this. Okay, at this point I can apply the power rule pretty nicely here. So you apply the power rule having 7/4x, and that's going to be 3/4, and then this one is going to be negative 1/2 x to the power of negative 5/4. Okay, at this point I don't like this one because you know that this is a negative exponent. So what I'm going to do here is I'm going to have the fourth root of x power 3, and then here you know that it's going to be a 1, and then you're going to have that it's 2, pass it to the denominator, clean up one of the x's, and you have this equation with the fourth root. Okay, why I took out this x, remember it would be here a 5, so I would take out 4 outside as a 1, and then I leave 1 there, and that would be it. Okay, that would be it. Now the next problem that we have over here is 9 divided by 5 times x squared. So this one, when I see it as 9 over 5 times x to the power of 2. This is pretty easy to do with the power rule because you would have negative 18 divided by 5 x to the power of negative 3. With this being said, you don't want the exponent to be negative, therefore you have that it's negative 18 divided by 5 x to the power of 3. Okay, and that's pretty much it for this problem. Isn't that simple? So the relatives that we have over here are the following. We have that tangent of x is going to be equal to secant square of x. We know that secant of x, the derivative of secant of x, is going to be equal to tangent of x, secant of x. The derivative of the cotangent with respect to x of x is going to be equal to negative cosecant square of x. And last but not least, we have that the derivative of the cosecant of x is going to be negative cosecant x cotangent x. So let's apply these formulas in the next example. The next example that we have a product rule. Okay, so you start with the 3x squared times the derivative of the tangent, which we know that it's going to be secant square of x, plus you know that it's going to be the tangent of x times the derivative of the 3x squared, which you know that it's 6x. With this being said, you have that as good as it gets here, it's not any better. You know that it's going to get as follows: 3x squared secant square of x plus, I would put the 6x at the front, tangent of x, and that's as much as we can do in this problem. Okay, we cannot simplify. I mean, you can take out the x and the 3 as common factors, but honestly it doesn't do anything to the problem that you have. I mean, I can put it here so you can be happy, but I mean, it doesn't make any difference for this problem. Okay, so you can have that as well. Okay, either this or this, both are correct, so we are good. Okay, so the last one that we have over here is sometimes we are given the values and its derivative to help us to evaluate a product or a quotient. In this situation, they give you that g of 2 is equal to 3, g prime of 2 is equal to negative 4, and h of 2 is equal to negative 1. In the same way that h prime of 2 is going to be 5. So they give you f of x, that it's defined as the product of g of x times h of x. They want you to find f prime of 2. So what I'm going to do here is you want f prime of 2. Following this idea, you know, using the product rule, that it's going to be the first one times the derivative of the second one plus the second one times the derivative of the first one. Okay, and this is with the x's. So what I do there, I just change the x's, and I'm going to evaluate that at a point. Specifically here, they are asking you to do it at 2, so change to 2. Okay, now you need to ask yourself, hey, do you have g of 2? Yes, it's 3. Then do you have h prime of 2? What's h prime of 2? That's 5. Okay, then plus, what do you have here? What's h of 2? That's negative 1. And last but not least, what's g prime of 2? G prime of 2 is negative 4. So this gives you that this is 15 plus 4, which gives you the beautiful number of 19. Okay, our conclusion here is you can conclude, I mean, you don't need to, but f prime of 2 is equal to 19. And that's pretty much it. I hope that you find this video helpful. Bye!